From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez.
It's a very interdisciplinary problem. And I think that's part of what draws me to it, because I enjoy, pulling those interdisciplinary teams together. As I'm a materials engineer by background, but, one thing I loved at Lockheed was being a part of an integrated product team, because I could sit there and look over the shoulder of the stress engineer and the designer, and, I got a lot more. I had no desire to do what they knew how to do. I appreciated it 100%. I never wanted to do it, but just sitting there and watching them do it and experiencing it with them, I always felt like made me better at what I was trying to do, because I understood where they were coming from, and I could then convert it into the materials and manufacturing solution that we could make it work.
That was John Barnes. John is the founder and managing director of the Barnes Group Advisors, a global additive manufacturing consultancy based in Pittsburgh. He joins the podcast to discuss his career path that started in defense and now impacts numerous industry sectors. We also talk about his team's work during the COVID pandemic, and he shares advice on building a team with diverse perspectives and skill sets. Welcome, John. And why don't we just get started like we do with most of the guests of where did you get your start in additive manufacturing?
My start came in the late 1990s. I was a young engineer at what is now Honeywell Aircraft Engines in Phoenix. And we had joined a CRADA with Sandia National Labs with 9 other companies to push a technology forward. It was 2 of the scientists were leaving the lab to create a new entity, which is now known as Optimec. And what we were working on was now known as the lens process. So it was kind of an interesting thing to be involved with, because the other 9 companies, so we had us, the jet engine company, and you'd expect like the usual suspects with Lockheed Martin was there, but Ford was there, and Hasbro was there, and 3M. So it was just really interesting to kind of take in what all these different companies saw out of this process. And so my usual joke at this point is it's because I was the least valuable engineer at the time, I was available to go work on this project, with Sandia National Labs. But for a young engineer, it's awesome because you get to go to Sandia, you get to see all this great stuff, and of course, looking back on it, just how incredibly lucky I was to have been given that opportunity for how much it's grown since that period of time.
Right. And the experience through that and seeing a lot of different technologies must have been invaluable even now. I mean, you've been running the Barnes Group Advisors for a number of years, but the kind of hands-on experience with so many different technologies through your experience is probably something you draw on every day.
It is. I think we take it for granted. A lot of the team have, we always say we've used the technology, we've qualified the technology. I've been fortunate. I probably didn't think about it until this last year that I think I've made stuff out of every additive form, that's out there. Well, at least that we officially define. So from binder jetting to sheet lamination, and directed energy from its beginnings, all the way through to some of the older technologies, SLA and whatnot, and just having had that experience that you take it for granted, but most people wouldn't, and that's, call it the luxury of working in defense, perhaps, that we have very unusual problems to go solve sometimes, and so it does take being aware of a lot of different manufacturing technologies. So as at that point in time, it was maybe not, sheet lamination at that point wasn't even considered to be an additive technology necessarily. It wasn't defined as such. It was just another way to make another option to make a kind of a heat exchanger, which is what we were interested in. But so I think I think once again, I just keep thinking that I've been extraordinarily fortunate in my career to have done that. But I also think it's a little bit like you create your own luck. I was always the type to be sticking my nose into projects to see where my group could help, because we did, a lot of times we certainly at Lockheed, we were always making weird stuff, and groups around us were making weird stuff, and our group was responsible for helping them make weird stuff. Maybe we only need to make it one time. So we had unusual technical challenges, but we also had unusual programmatic and cost challenges.
Yeah, and I suppose at the same time, you get this really unique inside preview of so many new technologies being in defense, right? Like stuff that may not come out. I mean, you may not see really at a trade show for a few years, and certainly applications don't come out for 3, 4, 5, even 10 years down the road. So you have all this kind of historical knowledge of where things came from, what were the first iterations of the technology and that material. And I always find that interesting in the additive manufacturing space, because it's we say it changes quickly, but some things it takes so long to get kind of out into the public space to really see how the full potential can be realized.
Yeah, and I think that we had, and at some level, it was like a great job to have, because not only did you get to kind of explore that cool space, but you became like the best friend of the company that was trying to do it. So we knew that we had very peculiar problems to go solve. So we had some, funding to be able to apply and say, hey, could you make this a little bit faster, a little bit stronger, put more power into it so that we can, we need more strength out of it, or, whatever the metric that we were choosing. And it was always like all these directions that these young companies could go. And so we were always just coming in saying, what could you be over here? If we gave you some money, could you be over here? Because that really solves our problem. And there was a lot of competition for the funding necessarily, but I think, like I said, it was a great job to have. I mean, because you were kind of a friend of the industry, and we didn't. Unfortunately for us, nobody on my team took that for granted. So we were pretty tight with our funds. We had to be. We didn't have, when we looked at our peers over at like Boeing, for example, they had the commercial airplane business to kind of add to their R&D coffers, and we didn't have that. we had significantly less, so we were trying to cover the span of airships which traveled at peak speed of 35 knots to hypersonic weapons that were hot and going quite fast. So made you kind of place your chips on things that you could be successful doing, and you'd make a difference doing.
Right, and so you got your start in defense and in Phoenix and kind of the West Coast, and for the last few years you've been running your own company, the Barnes Group Advisors. How did that get started, and what was the motivation there?
Well, it got started based off of my last job, actually. So I had been living overseas in Australia and was running a research program for the National Science Agency, the CSIRO. And we'd made the decision, as a family to move back to the US. And so I went to work for a company called RTI International Metals. And so on my first day, we were still living in Australia, and I was, working remotely for the first 3 months until we could, because the schooling system is obviously different than it is in the Northern Hemisphere, as are the seasons. And they said we were getting bought by Alcoa, and so that kind of put things into some question as to what was going to happen next. And once we arrived in Pittsburgh, we moved into the Alcoa building, and then it's mentioned that they were going to be splitting the company and creating what is now known as Arconic. And so it was just kind of like a continually shifting kind of milepost. And so eventually was a kind of a convergence of events. It was just kind of like, well, this isn't the job that I was necessarily, interested in when I came on. It's a little bit different mission. This additive thing really seems to be taking off. I have a decent level of experience across a wide spectrum of positions, and kind of had an idea that I wanted to pursue as a startup as well, and I needed to be separate. So that was kind of the essence of it. It was really kind of saying, well, this additive thing is gaining momentum. It's real. It's on airplanes now. My team had just qualified the part for the A350, so that was giving me a lot of confidence that this was it. And the thing that I noted is that routinely I was always being asked if I knew, somebody someplace. And just because I'd, been bouncing around the industry, I don't consider myself to be an extrovert at all. But I had pretty good connections because I was, part of my job at Lockheed was connecting people. Part of the job at Arconic was, connecting people and companies. And so I thought, well, maybe that's something that people would pay for. And lo and behold, they will. So I think it's a culmination of, just the way that what I hoped would be true, which was, if you do a good job for people and make some good connections but with a sense of purpose, that, people will find value in it. And it's been a pretty rewarding process, as you know, and I'm sure, the challenge always is, I always tell people that it's terrifying and exciting at the same time. Because there's never, it seems like I had no idea. There's so many questions. I mean, there's so many questions that people ask, and it just never ends. And I always amazed that I don't have answers to most of the questions. I didn't even know that a lot of the questions existed. So I think that's been a learning for me, which doesn't, necessarily have anything to do with the company, but it's been a fun ride, and it's been enjoyable because other people have come to want to be a part of it. And so this is kind of the team that we have. So
and how many people are you guys up to now?
Yeah, we're up to 14, but not all full time.
Yeah.
So, part of our model is accepting people who just, they may be retired, or they may be a lecturer at a university. So they can't or don't want to work full time doing this. And in one case, we've got somebody who's retired from 30 years at Boeing. They're too early to, watch Matlock all day. And they don't really enjoy playing golf. So this is the kind of the perfect thing for him. He can maintains his connections in the industry. He gets to do some technical work, and we don't force him to attend staff meetings. So it's kind of it's a win-win.
Although I do see periodically on LinkedIn, you guys have your happy hours on Friday, so there must be some sort of interaction at least.
Yeah, so
virtually.
that's how you know you're being successful, when people voluntarily come to join in on a Zoom session and enjoy a cocktail in the afternoon. So it's been that's been kind of a learning for me. We typically hadn't been doing staff meetings. And for all the reasons that you'd expect, it's just like people don't like them. There's some value in the communication. We do make sure that we're communicating. We do kind of weekly highlights, and we do quarterly sessions where we bring everybody together. And then we do an annual get together. We won't be doing an annual get together this year, but we're going to work out an alternative way of getting together. And so what started off was, look, we don't know what's happening with this pandemic and this quarantine. So let's just kind of, get together and not talk about, we don't have to talk about work. We start off playing, some games that you can do online. So one person beams it on their laptop and you join on your phone, and you can play these things. It's pretty funny. And but you're learning more about the other people too. So while I know everybody, I have a pretty good, in most cases, a long-term relationship with the team. I always forget that they don't often have that connection. Their connection is through me. They may be aware of the other person, but they don't have a personal connection to them. And so it's been very good for that. But I keep learning about, people on the team, and I guess they keep learning about me. They still stick around, so it can't be too horrible. Although I wonder at times, but I found it to be really interesting. I mean, it's paid rewards that I hadn't imagined, and I think for me, when I look at like how Laura Eli, how I think we're an interesting pair to kind of manage that, because she complements me in ways that, we just complement each other from a skill set largely. So I find that the combination has been really interesting. So those, as we call it, the half hour social hour, has been, a great investment of time, and has provided me with kind of an appreciation of learning that I certainly wasn't expecting, but I'm better off for it.
Sure. And certainly during this COVID time, we were talking a little bit before this started, that you guys have actually done quite a bit of work in helping folks around the Pittsburgh area and coordinating some of the relief efforts related to the pandemic. And you speak a little bit about that.
Yeah, we were sort of connected back and forth it was actually over a weekend, where I had some connections at, so Dr. Jay Morris at the Mayo Clinic, and Andy Christensen out in Colorado. So Andy had a medical device company that he sold to 3D Systems, and so we were just talking on the weekend. This was really back in either late February or beginning of March, and trying to get us what is really happening. I mean, one of the casualties of these types of event is the information is hard to come by, and it's obviously not as bad as some people are saying it is, but it's not as good as other people are saying it is. So you just don't know where truth is. And, so it was in that kind of conversation where Dr. Morris really, I think he was telling us what he sees, and Andy and I were just kind of like, okay, well, we've got to do something. I don't know what it is, but we've got to do something. And so I called my team together with Andy, and we kind of described the situation and what we thought would be requirements for that. And so that ultimately became the austere mask that we haven't spent a lot of time talking about, but we ended up working collaboratively with the VA and Dr. Beth Ripley's team out in Seattle, which ultimately wound up in a CRADA. At the same time, though, we became connected to this group in Pittsburgh that was kind of stitched together by, it was really just one of these weird events where I think John Hartner from X1 started asking people to participate. And then Marcus Schmelius, Professor Schmelius from University of Pittsburgh. And then we had ANSYS, and I'm going to forget some people, but UPMC, which is based here in Pittsburgh, medical insurance, the medical people. We were discussing, like, how do we create filters? How do we make different types of devices because of this mask shortage? And so I think University of Pittsburgh and X1 kind of went down a path of, we discussed metal filters and specifically, and this was kind of a conversation. I said, well, it seems to me like if we do a metal filter, that's an interesting component, because you can sterilize it relatively easy. You can drop it in boiling water, you can run it to an autoclave, and then you just use it over and over again. And when you're short on things like masks, you don't want to, those weren't made to be reused. But if we could adapt this metal filter and it filters out the virus and you can reuse it, that's kind of a nice combination. So they went down a path. We we,
So kind of
certainly tried.
was that using binder jetting and
Yeah. So it's
okay.
really looking at, because the traditional way you'd make a metal filter is through powder, just sintered powder filters. And in effect, the binder jetting, can allow you to do the same thing. So that was kind of their twist on it. We did look at, what was currently out there on the market as an alternative, just to say, okay, well, maybe we can go get a membrane from a beverage filter and we can get it to do the same thing. So that was one path. And then we kind of led a path looking at what I would have called a tortuous path. So this is the idea that if you create, you don't have to make very fine features, but you create a path. So it's like a design that you're forcing air, and the particles will, um, basically collide with the walls, and that then creates its own separation. And so we ended up partnering with Wabtec and SLM Solutions and Intopology, along with a few others. But we kind of came up with a concept. We, Wabtec had designed particle separators before, but nothing, for this size scale. And what we found was we were pushing the boundaries of printing, really, because to get to the details that we wanted to get to, effectively all you were doing was contour printing. So you had to trick the printer into doing no fill and only do contouring, and it, some printers like that and other printers were okay. So fortunately, with SLM Solutions helping us, Kyle, figured out how to control the printer into doing what we wanted. And so that allowed us the flexibility to say, okay, well, if we have a requirement for this size or this wall thickness or this opening, now we've got an ability. We know what our machine is capable of delivering, and we'll have to, adjust accordingly. And then another thing that we learned along the way, and I'm sure you certainly would appreciate this, is that, creating lattice structures in CAD is not an enjoyable task. So, then we just happened to ask, we forget how I think we started with Brad Rothenberger at Intopology, and he was like, yeah, we'll help. Sure. And, so, their software is very good at making lattice structures, especially repeating lattice structures. So, it saved us all that design time and trying to, CAD a lattice structure as a filter versus just, having Intopology or our code go in and calculate something. So but it isn't 100% of anything. So it was, we used traditional CAD where it had advantages. We used Intopology where it had advantages. And then we used the printing capability that we now knew, so we could, do these fine features. So we could tell the printer, only contour here versus the rest. We need to do, conventional printing with it. And so that was a really interesting experience. And so we had, just within that little community of Pittsburgh, we were reaching out to Intopology in New York and SLM Solutions in Detroit and the VA in Seattle, ANSYS, which is located here in Pittsburgh, X1's in Pittsburgh, and then there was a loose affiliation with Texas A&M, and it kind of impressed me that Pittsburgh had this reach, and so it was rewarding anyway to be working with this to try to solve this problem. And so we designated ours the forever filter because it would last forever. And so we're still working on some development on that with Wabtec, and I think University of Pittsburgh and X1 are still kind of working on the sintered design. But it was interesting because later on I came across some research that we were doing with Carnegie Mellon in their engineering and public policy class, and they showed me this statistic, and we were looking at how Pittsburgh compares to other places which are kind of up and coming, like Alabama, specifically the Huntsville area, and North and South Carolina. So South Carolina has been very ambitious with getting manufacturing, especially from European manufacturers. But the connectedness isn't like Pittsburgh's so much better connected globally through these kind of either personal connections or cognitive connections versus Alabama and the Carolinas. And so basically the crude way to think about it is that those states can continue to write checks to companies to come there. But if you come to Pittsburgh, you're then immediately an order of magnitude better connected. And that to me was really kind of a fascinating thing to learn throughout this whole process. So
do you think is that because of the university connection, having Carnegie Mellon and University of Pittsburgh, these very global universities locally versus?
I think, yeah, I think that has a lot to do with it. Pittsburgh has a high degree of, advanced degrees per capita. So, academics are naturally inclined to talk to other academics. So I think that's a component of it. But the other component is that Pittsburgh, still maintains, some of its cultural identity through, it was a big German population here. So there's still a very large German chamber of commerce. There are, we're sister cities to Sheffield. Sheffield and Pittsburgh are very, very similar in most respects. So I think those connections also help. People have maintained their family connections back in Europe. So I think that probably has something to do with it. I'm sure there's a better explanation than what I'm coming up with, but I think it's fascinating.
And once a Steelers fan, always a Steelers fan, or Stillers.
Stillers. Go Bucks.
Yep. And kind of speaking of the universities, I mean, part of the kind of diverse range of projects that you guys do throughout the additive space, not only are commercially focused, but you guys kind of do a lot to help propel the next generation of additive engineers and people in the industry through some of your work with, I think certainly Carnegie Mellon and others. Do you have any kind of recent stories about that work?
Yeah. We, for us, it's, as we always tell people, we're a consulting firm. It's how we do business, but we don't like to be called consultants. There's a definite vibe that consultants give off. It's what we do. I think we're helpful to that end. We recognize that we need to be, where I think we're different is that we make it a point to be kind of part of the fabric of the industry because a lot of us have been in it for a while. And so whether it's being an adjunct professor at Carnegie Mellon and going and talking to those classes, either teaching or giving them a perspective from industry on how to do things. We recently sponsored the engineering and public policy class because for me, I love that stuff. I love the combination of policy and process economics and engineering. I think that's where engineers, ultimately provide huge amounts of value. But that I know I'm biased because maybe I wasn't as strong as with free body diagrams as some others. And then we also do, we've done a senior project for the last 2 years with Medtronic at Purdue University. And, part that has allowed us other things. So we really try to make an impression on them with, the whole processing properties, performance triangle that, additive is still, that is a reality. Just because it's additive, it still matters. The process of additive greatly then dictates the microstructure, which then dictates the performance. So you really kind of have to take a look at it. And, the universities just haven't caught up yet to kind of convert or to include processing to also include additive manufacturing. It is a popular subject, but not all the universities have kind of caught up to that yet. And, we've had an intern from CMU. Also, important for us is kind of the gender equity issue. Because I've got 2 daughters, it's something that's, close to me, and we've taken a look at it, and it's we'd love to be able to hire, just, have as many female engineers as we do male engineers. And we certainly have that opportunity. I'm not suggesting we don't, but if you look at it from an industry perspective, about 20% of engineering degrees today are awarded to females. So at some point, industry has no ability to hire female engineers because we're not graduating enough female engineers. And I don't necessarily have reasons for why that is, but we try to provide incentives and reasons for women to get in there. Certainly, just talking about awareness of the different types of engineering degrees that are there, what you do with an engineering degree. When I look back when I was in high school, the only reason why I was interested in engineering is because I loved planes and I wanted to be a pilot. I was going to be a naval aviator, like Top Gun. And then I got into school and I was like, okay, well, this engineering thing's hard. I should probably design airplanes. That seems like a better solution than flying them. I can always fly an airplane later on. But that's how I kind of got into it. My parents weren't engineers. I wasn't from a technical family. So I didn't have an awareness of what engineering was. And so I'm sensitive to that subject, making people aware, specifically women, because if they don't go into engineering, they're clearly not going to get an engineering degree. Then they're not available for people to hire it. For me, running this small business, it's the balance of the people and sort of the personalities and the background and everything that I think gives us a better answer a lot of times. So, it's important for us to maintain that kind of diversity of thought, and it comes from different academic degrees, it comes from different personal backgrounds, but that's one thing that's important to us. And I don't honestly, I don't know that we know how to. We're certainly not going to solve it ourselves. So we just try to make a little bit of a difference, where we can. And so we have people that donate time to Missouri University of Science and Technology, to University of North Texas. We have people that work at Penn State, lecturers in the UK. I also am an adjunct professor at RMIT University in Australia. And so wherever people ask for stuff, I think we try to be as generous as we can with our time. And then everybody donates time with different professional societies and being on committees. So I'm an AM advisor with SME, and that's been a very positive experience for me, because it's also being around a lot of people. I think there's 14 or 15 of us that all have a lot of experience in the additive world. And I'm very happy that, half of our team is female and half's male. So we have this kind of very balanced view of when we go discuss stuff. And I think that gives us a bit of an edge and an advantage back to SME. But, we're also involved. I serve on the SAE AMS, reviewing specifications, which isn't isn't the most fun. I'll be honest, but thank God there's people out there doing it, and I just try to provide some experience when I can. But it's important because the industry is growing, and I just think that young people like the industry, but they'll stop liking it at some point, and I don't know how we keep that in there, but manufacturing has suffered because people don't find it compelling or interesting. And I think people don't look at 3D printing or additive manufacturing as manufacturing, which is good at some level, because they don't have the negative connotation association with it. So I don't know, that was a long and winding path to answer your question, but that's a big subject, I think.
Right. And for me, I think the fascinating thing about additive manufacturing, and you probably see this every day with your team and the types of work that you're doing, is you're answering very different types of questions. It could be a materials question, it could be a process question, it could be a design question. And all of these challenges in the industry require different perspectives, different educational backgrounds and to get
yeah,
to a solid answer?
it's a very interdisciplinary problem, and I think that's part of what draws me to it, because I enjoy, pulling those interdisciplinary teams together. I mean, as I'm a materials engineer by background, but one thing I loved at Lockheed was being a part of an integrated product team, because I could sit there and look over the shoulder of the stress engineer and the designer, and I got a lot more. I had no desire to do what they knew how to do. I I appreciated it 100%. I never wanted to do it, but just sitting there and watching them do it and experiencing it with them, I've always felt like made me better at what I was trying to do, because I understood where they were coming from, and I could then convert it into the materials and manufacturing solution that we could make it work. But additive is so incredibly interdisciplinary, and that's one of the things we try to tell people in our training. We talk about that it's a team sport. These these devices are quite complex at one level. There's optics and physics and chemical engineering, mechanics of materials, and mechanical engineering. I mean, there's so much going on in there that just requires that kind of team approach to get the best out of it.
Right. And speaking of that, and adding on to some of the Pittsburgh connections, you guys have a pretty unique initiative going with Neighborhood 91. And do you want to tell us more about that? I was reading a little bit that the name came from, I guess there's 90 different neighborhoods in Pittsburgh, and this will be number 91 with a focus on supply chain and manufacturing.
Yeah, it's been a very interesting and rewarding project to be a part of. I was again fortunate through some connections, learned that the airport, the Pittsburgh airport, was putting together this innovation campus, and the reasons for doing so was really trying to promote. They sit on a lot of land, so it's not widely known. It's a fun fact. So for your trivia questions, Pittsburgh is the 7th largest airport by land mass. So it has 8,800 acres.
Wow.
So that allows them to do some things that other airports can't. And so when they look at real estate development, they've got quite a lot of land that they can develop into things, which then helps drive the need for air travel to and from any kind of region. And I got asked to go to a meeting, it was about a year and a half ago. It was at the University of Pittsburgh. The airport CEO was there, Christina Casadas, and Chancellor Gallagher from the University of Pittsburgh, and a whole host of other people. And so it happened quite quickly. Once we kind of pitched the idea of this additive manufacturing and the supply chain issue, and if you look, we just drew a circle of 2 hours around Pittsburgh. So you can go all the way, that encompasses Cleveland, goes out to State College and through West Virginia and Ohio. The entire supply chain for additive manufacturing exists. It's just not connected. And so the idea of just bringing it into a 200-acre campus started to make a lot of sense. And that's, one of the things that we found is limiting additive manufacturing at the moment, specifically metal, is this disconnected, fragmented supply chain. It's adding in costs that we can't afford, and we need to get cost out. And so it kind of progressed pretty quickly from there. And so we worked with the airport authority on some of the marketing. And so initially we were headed down the path of a name that was an acronym, and then we kind of had a thought about it, which was, well, that's kind of out there. It's been done. When I was at the CSIRO, we created an additive manufacturing lab, and we had a contest, and one of the guys came up with Lab 22. 22 is the atomic number for titanium, which was the origin of that particular group. So this was a lab, Lab 22. It kind of gave it like Area 51, flavor. So we went with that, and so the team went off and they came back with a couple of options, and one of the options was Neighborhood 91. And somebody who's not from Pittsburgh, you hear the story about the 90 distinct neighborhoods in Pittsburgh. So then it just made a lot of sense. And you got Mr. Rogers neighborhood, and the fact that you don't necessarily, I don't need to buy a bandsaw, Mike. If you've got one, I just go across the street and use your bandsaw. I'll pay you for it. I'm happy to pay you for it, but we both don't need bandsaws. So that's goodness. That's an immediate cost benefit to both of us. So that's kind of the idea around this thing, is that it's a supply chain campus where we're working to get each point of the supply chain represented. We started with parts manufacturers, and we've got now a test lab, we've got a heat treater, we're looking for inspection, we're looking for powder production, so all these other elements. And the idea is that we're the invisible hand of the market takes place. There's an incentive for those people to do commerce with themselves. We also are encouraging this behavior because we've through the airport and the state have made investments in infrastructure. So we will have argon recycling on campus. We will have a microgrid that will provide very resilient electricity. So there's no need for UPSs or generators or any of that. We're providing a central powder storage facility. So people don't need to spend money on outfitting a special corner of their facility for storage of powders. Recycling of argon is not an inexpensive proposition, but once you do it, the cost of argon drops dramatically. And if you're making metal powders, that's a huge component of your cost. You print things, you use argon. And when you heat treat things, you use argon. So it's a pervasive cost element across the campus. So we kind of turn that argument when people say, well, do we have to do business with each other on the campus? And we're like, well, you don't have to, but I think you're probably going to want to. And I think probably the next thing is that people will want to do business with you from the outside because you're getting this inherent cost benefit. So it's a pretty interesting project to be a part of. I was not born in Pittsburgh. My mother was, and so that's kind of an interesting twist, because not only does every Sunday she ask me why we're not done with Neighborhood 91 yet, but she wants to know what's going on. She wants to know when parts are going to be started to come out, and all of that. But it's it's not every day you get to be part of building a production campus, and I think that was an important thing. So we wanted to go to, we made a special effort to go visit University of Pittsburgh and Carnegie Mellon and some of the other stakeholders, and said, this is a production campus. We are not doing research and development. When we're successful and we've got people on site producing things, they're going to have problems, they're going to need R&D, they're going to come to you. And like, everybody got it immediately. There wasn't any consternation about it, but we didn't want people to be concerned that this was duplicative of any way. And so I think that's another really interesting thing about Pittsburgh, is it has a willingness to just sort of work together. It's not a very arrogant city. It's got a lot of civic pride, and it's been easy to work with people here. So that's been encouraging.
Awesome. And so as we start to wind down the conversation today, you guys have also been doing some interesting discussions along the lines of supply chain with your kind of summer leadership series. Before we go, do you want to just tell people where they can find out more information about the Barnes Group Advisors, and then maybe preview a little bit the leadership series that you guys have coming up?
Yeah, we've taken this summer, we decided that we kind of step out of our comfort zone a little bit and do this summer leadership series. So the first topic was supply chain. We did a survey. We brought in some key people from the industry to talk about what's really happening, and have important to us was actually to have an actual dialogue. So that wasn't just like people advertising their capability. Next week, we're going to be having, on July 30th at 11 a.m. Eastern time, we're doing the second installment, and we're specifically looking at production and additive manufacturing. So we've got a really nice panel set up. Joe Christner from SLM Solutions, president of North America. Jonathan Meyer from AP Works, had been a long time at Airbus before that. And Anjani Achanta from Baker Hughes. And so we've kind of, again, got a value chain proposition going there. The dry run that we did, almost took us a full hour, and we didn't, we still had plenty to go. So I think it's going to be a really interesting, like, all these individuals are fascinating to listen to, because they've got a lot of experience in general, but they've got a lot of experience in additive. And I think part of our conversation is that, qualifying things in additive is really the same process than qualifying them in, any manufacturing technology, but there are some uniqueness that additive brings. So if people want to find out more about it, they can go to our website, Barnes Group Advisors, thebarnes.group, and we've got more information about it there. I think we're close to maxing out our registration. So make sure that if you're interested, don't wait till the last minute, because I think we're limited on how many people we can host. And but we will have a recording that will be available afterwards. And then our last one is going to be in another month, so the third in the series, and it's really going to focus on what have we learned, so, which I think is a rich question these days. What have we learned about PPE? What have we learned about supply chains? What have we learned about ourselves, throughout this process? And so we're going to have almost a CEO, a senior panel to kind of go through that and look for what I feel I think where all these individuals have great leadership lessons, whether they're truly, the traditional leader, or they just emerged as a leader and decided to paint their own direction.
Fantastic. And we'll post some links to all those sites as well. So John, I appreciate the time today, and thanks for the great conversation.
Yeah, thanks for having me, Mike. It's been fun.